Hi everyone, so in this video we are going to start vector calculus and I hope you must have seen the previous video. The previous video was based on assignment but some basics of vector calculus we covered there. We studied what is scalar function, we studied what is vector field function. So those functions we have studied. So those will be highly used here, and here I am not going to explain what do you mean by vector field function and what do you mean by scalar field function. Okay. So before starting the vector calculus part, let's see very basic of differentiation, very basics. So you need to partially differentiate this scalar field function with respect to x and y and z. So what is the first question? You need to partially differentiate with respect to x. So del y del x. What is the function? X square y plus yz. I can break it something like this. If you already know it, then you can skip it. Okay. Plus del by del x yz. Okay. So here, what do you mean by partial differentiation? It will be done with respect to one variable and other variable will be taken as constant. So y will be taken as constant. Differentiation of x square 2x plus, here there is no term of x, so that will be 0. So answer will be 2xy, right? Let's do the next one, del f by del y. So del by del y, x square y plus yz. So here del by del y, x square y plus del by del y yz. So what will come as a constant? X square will come as constant. Why is that so? Why x square is coming as a constant? Because you are differentiating with respect to y. So del y plus, what will come as constant now? Z will come as constant, and then del y by del y. So what will be the answer? X square plus z. Okay, x square plus z. The last one, del f by del z. So del y del z, x square y plus yz. So this term will give you 0, right? Why it is giving you 0? Because there is no term of y, and the second term will give you y only. In the first term there is no term of z. In the first term there is no term of z, that's why it is giving you 0. Here what will happen? Del by del z yz. So y will come as a constant outside, and del by z del z will give you 1. So y into 1 will be y only. So that's why you are getting y here. So very simple thing. I hope you are already knowing this much of basic things, right? So this was your partial differentiation. Just quickly let me know which one is a vector quantity, which one is a scalar quantity, and which one of the following operation is not valid. Okay. So tell me, what is this, vector or scalar? Vector quantity, because it is just a vector which magnitude is amplified by factor of 5. Basically, let's just say my vector A was 2i cap plus 3j cap. I am just amplifying the magnitude by the factor of 5. So 10i cap plus 15j cap. This is what I am doing. Okay. So this is a vector. Now dot product will always give you scalar quantity. Cross product will always give you vector quantity. Now this is a vector. B cross C vector. Vector cross product with vector. What it will give you? Vector only. Now this is a vector. Vector dot product with vector. What it will give you? Scalar. Again repeating. This is a vector. Vector dot product with vector will give you scalar. Tell me whether it is valid or not. Cross product and dot product are defined for what? Vector quantity. Here also there should be vector, and here also there should be vector. Here also there should be vector. Here also there should be vector. Now this is your cross product, but here there is scalar quantity, so it is invalid, right? This is not even a valid operation. Same goes here. This also should be vector, so this is also invalid operation. Okay. Now let's start our vector calculus. So one basic prerequisite we have seen, that was of around 4 minutes. So now let's start our vector calculus. So in vector calculus, just like any other calculus, we are going to study two things: differential and integral calculus. In differential calculus, we are going to study about gradient, divergence and curl, and in integral calculus, we are going to study about line integration, surface integration and volume integration. Line integration could be of two type: open and closed line integration, and surface integration could be of two type: open surface integration and closed surface integration. So one by one we will see. First we will start with differential calculus. Okay. So before starting the differential calculus, you should know what is vector field and what is scalar field, and all those have been explained in the previous video with very detailed examples as well. So here I am only gonna write example. So what is the example of a scalar field? So it will be completely scalar. So xy plus z square plus zx. This is one of the example of scalar field. What could be the example of vector field? So anything it would be, just it would be a vector. It would be a vector. So this is representing a vector quantity with respect to variation in space. Okay. Now when we study differential calculus. So first we will study about differential calculus. When we study differential calculus and when we study integral calculus as well. So there will be something that we use that is known as del operator. So there is one operator we are going to use. What do you mean by operator? Multiplication is an operator, addition is an operator, subtraction is an operator, division is an operator. So one more operator is there which is known as del operator. And how do you represent it? This is how you represent it. You cannot use vector sign here, okay? On the del sign you can never put a vector sign, but it is a vector quantity. Let me write it more clear. This del operator is a vector quantity. But you will never use vector sign here. But in that mind you will think that okay, it is a vector quantity, so vector sign is there. It is available but I cannot see it. So in Cartesian coordinate system, how will you represent the del operator? How will you represent? Del by del x ay cap plus del by del y, sorry, del by del x ax cap plus del by del y ay cap plus del by del z az cap. So this is your del operator. This is a vector quantity in Cartesian coordinate system. In cylindrical, how it will look like? So in cylindrical, how do you go? D rho, rho d phi, and then d rho, rho d phi. Here we will only do the partial differentiation. D rho, rho d phi, and dz. So similarly, I need to write plus 1 by rho d phi plus dz. So in that one I need to go. Similarly for spherical, how will you write it? You can write it on your own. Dr, r d theta, r sin theta, d phi. So similarly, let's write it. Dr, r d theta. So 1 by r, 1 by r, r d theta plus 1 by r sin theta d phi, del by d phi a phi cap. Okay, this r doesn't seem okay. So this is how you are going to write it. This is your del operator. You don't need to mug it up. Eventually you are going to remember it because you will solve a lot of problems. Now we will start studying about gradient. So first we are studying about differential calculus. In differential calculus, we will use this del operator, which is a vector quantity. Sorry, which is a vector quantity. Yeah. So this del operator is a vector quantity. It will perform operation on scalar field as well, and it will perform operation on vector field as well. So it is a vector quantity, right? Now, if I write a direct scalar function, this is my scalar function. This example I have taken here. So let me know what this quantity will be. Is it a vector or a scalar? What I am doing, del f, this is what I am writing. This is a vector quantity and this is scalar. So what I have written, a vector multiply by 5, not cross, multiply by 5, not cross, multiply by 5. So basically this 5 can come here. So what this will be? Vector quantity. Here we saw, no, this is a vector quantity. So del f, I am not saying del dot f, I am not saying del dot f, no, I am neither saying del cross f, no, del multiplication f. So this is known as gradient. Okay, if you are performing the operation on scalar field, that is known as gradient. So del f. In divergence, starting from d, so you will do the dot product. You will do the dot product, but this will be a vector function, and here you will do the cross product starting from c. C stand for cross, so here you will do the cross product, but Here you will do the cross product, but these will be vector quantity. If you are doing the dot product and cross product, certainly they have to be vectors. So this is your vector field, vector field function you can say, or vector field, and this will also be your vector field, and this is your scalar field, field. Now let me know what this quantity will be, the result, del f I am asking, del f I am asking. Just now I told you it will be a vector quantity. Now vector dot vector, what it will give you? This is a vector quantity, or I should say result is vector, result is a vector quantity, because del is a vector and this is just a constant which is multiplied. So what will be the answer? Vector quantity. Here what will be the answer? Scalar, because vector dot vector, what it will give you? Scalar. So result is a scalar quantity. You don't need to mug up all these things, because you will eventually understand, because you will solve a lot of problems. And what this will be? Vector cross vector. So result will be a vector quantity only, because vector cross vector will give you vector only. A cross B will give you vector only. A dot B will give you scalar, and 5 into A vector will give you vector. So this is what we have written. Okay, so let's start with the gradient. Now what will be the flow of understanding each point? First we will understand by gradient, then we will understand divergence, then we will understand curl. So what will be the flow? First we will see formula, and then we will solve some formula based problems. After that I will tell you the physical significance, that what is the meaning of gradient. That I am gonna tell when we are finished doing the formula based problems. So initially there will be completely rote learning. You will feel like that, sir, you taught previous chapter with full amount of enthusiasm, with full amount of interest, but why you are doing rote learning here? Rote learning will be initially, because if I just start explaining you the physical significance directly, then you are not going to understand it. So I want your full concentration and patience as well. So first we are going to see only the formula, then I will explain you in a great manner that what is the physical significance of gradient. So you need to have some patience. We will solve enough problems, we will see the physical significance as well. So let's write down the formula first. So gradient of a scalar function, gradient of a scalar function f is given by, how it is given by? Del f, not dot, del f. This is how it is given by. So different coordinate system have different formula. So for Cartesian coordinate system, what is the formula? Here I will write down for Cartesian coordinate system. So formula is, you will have to remember it actually. So this is a scalar field function. So this will come as it is, ax cap, and you know it will be what? It will be a vector quantity. So you do not forget to apply ax cap. Then del y, then f will come as it is, ay cap, plus del y del z, f will come as it is, az cap. If you are not making your own notes, then write it down in your rough notebook at least 3 times. At least 3 times I am saying. Okay, quickly write it down. What about cylindrical coordinate system? How it will go? So what you wanna write? D rho d phi and dz. So del y del rho, field will come, because it doesn't have any rho phi z function. Why it doesn't have any rho phi z function? Because it is a scalar field. So scalar field will be somewhat like this. It doesn't have any rho phi z function, right? So del f by del rho, a rho cap, plus rho d phi. So 1 by rho d by d phi, and f as it is, a phi cap, plus d by dz, f as it is, az cap. What about the next one? dr r d theta, r sin theta, d phi. Okay, all should be del only. These should be del only. This also should be del. So del f, or gradient of f, r f ar cap, plus 1 by r d phi, r d theta, not d phi, r d theta, f a theta cap, plus 1 by r sin theta d by d phi f a phi cap. Okay. So this is del f, this is also del f, and this is also del f. Dr r d theta r sin theta d phi, then del f del f del f. Ar a theta a phi, a rho a phi a z, ax a y a z. So you will be able to remember this formula. Absolutely. Now let's just solve a problem just based on formula based. I will tell you the physical significance, but hold on to the video. So first I need to write down what will be my del u by del x. Since it is giving in Cartesian coordinate system, so I can write down del u, sorry, what I need to write down, this I need to write down. Okay, so what that would be, del y del x, x square y plus x y z ax cap plus del y x square y plus x y z ay cap plus del y del z x square y plus x y z az cap. So y will be constant 2xy plus here yz will be constant and x will be differentiated, so that will be 1. So partial differentiation we have already seen. So this will give you 2xy plus yz ax cap plus here x square, differentiation with respect to y will be 1 only, plus xz ay cap. What about this? So here it will give you x square y will give you 0 and here it will give you xy az cap. Okay. Now you need to put the point. This is your del u. So at a particular point they are asking. So at 1, 2, 1. So what will be the value? So 1, 2, 4 plus 2 ax cap plus 1 plus 1 ay cap plus 2 az cap. So what is the answer? 6 ax cap plus 2 ay cap plus 2 az cap. That's it, simple calculation, nothing else. Let me match the answer so that there is no error. So these are very standard question from this particular textbook, which is Sadiko's textbook. So from here we are getting these questions. So 2xy plus yz plus x square plus zx plus xy. Then I just put the value. These values I have taken on my own only. So 4 plus 2 plus 1 plus 1 plus 2. So 2, 6. Okay. Yeah, that's it. Now let's calculate the second one. Del v you need to calculate. So second, del, not dot, dot will not come. Del v I need to calculate. So rho, with respect to rho, what will come? All these complete function will come. Rho z sin phi plus z square cos square phi, rho z sin phi plus z square cos square phi plus rho square a rho cap plus 1 by rho d phi. So rho d phi, and then the same thing will come, rho z sin phi. I'm not gonna write everything, okay. I can differentiate in my brain only. So that's it, and then a phi cap plus d by dz, then rho z sin phi plus z square cos square phi plus rho square az cap will come. So now we need to differentiate this. So with respect to rho we will differentiate. So z sin phi will come common. Here there is no term of rho, so this will be 0. Here this differentiation will be 2 rho a rho cap plus 1 by rho is outward. What about this? So in the first term there is phi. So in the first term there is sin phi. Differentiation of sin phi is cos phi. So rho z will come outward because I am doing the differentiation with respect to phi. So rho z cos phi plus in the second term as well there is phi. So z square will come outward. So z square 2 cos phi, and what is the differentiation of cos? That is minus sin phi. So it will be minus sin here. Okay, so that will be a phi plus this will be differentiated, and then rho square will be differentiated with respect to d phi, that will be 0 only. Then here differentiation with respect to z, so z will be differentiated and rho sin phi will come out plus here 2z cos square phi, and rho square will be 0 only. So that's the answer. Let's check it. Z sin phi plus 2 rho z cos phi minus z square rho sin 2 phi, sin 2 phi or cos 2 phi? This should be cos 2 phi. Sin 2 phi, okay, fine. Rho sin phi plus 2z cos square phi az. Okay. Now I need to put the point. What is that point? 1 comma 30 degree comma 2. So point is 1 comma 30 degree comma 2. So 2 sin 30. What will be sin 30? 1 by 2 plus 2 rho. Okay, and 1 by rho is 1 only. Here I am putting 2 sin 30, 1 by 2 plus 2 rho is 1. Here also rho is 1. Now rho is 2 here, sorry, rho is 1 and z is 2. So 2 cos 30 is root 3 by 2 minus 2 z square 4. And what about cos phi? Cos phi is root 3 by 2 cos 30 degree, and sin phi is 1 by 2, right? A phi cap plus rho. This is just calculation, no one will ask you in the examination, so do not worry about that. Rho is 1, phi is sin 30, sin 30 is 1 by 2 plus z is 2, so 4 cos 30, that would be 3 by 4, because cos 30 square is there, 2 into 2 4, and cos square 30 3 by 4 az cap. Okay, so 3 arrow cap plus root 3, this is your root 3, and here 4 and 4 will get cancelled, minus 2 root 3 it would be, right? This is 4 minus 2 root 3, so minus root 3 a phi plus here 3.5 az cap. Just calculation based problem, nothing else. No one will ask you this thing. Just I wanted to show how to do the calculation. If any day you need to do it in the examination, then you should be able to do it. Okay, so this is how you do the calculation. So 4 minus 2 root 3, so minus root 3 it would be, and this is 4 3.5 az cap. Okay, let's solve the last one, and then we will move to physical significance. That will be very interesting. So del dot w, not dot, there is no dot here, I am not applying any dot. Yeah, so dot is not there, dot product, it is not dot product, it is simply del w I need to write. Okay, del w, so d by dr, so what I need to write? Dr r d theta and r sin theta d phi. Okay, so dr, then cos theta sin phi ln r, cos theta sin phi ln r plus 1 by r d by, and here I forgot to write ar cap, plus 1 by r d by d theta cos theta sin phi ln r. This will be your a theta cap plus 1 by r sin theta d by d phi cos theta sin phi ln r a phi cap. Okay, cos theta sin phi and differentiation with respect to ln r will be by r, ar cap plus 1 by r with respect to theta I need to do. So ln r will come outward, ln r and sin phi will come outward. So ln r by r sin phi, what will be the differentiation of cos theta? That will be minus sin theta, right? Differentiation of cos theta is minus sin theta, and then 1 by r sin theta, what will come with respect to phi you need to differentiate. So cos theta ln r would come outward. So ln r cos theta divided by sin theta, that would be cot theta. So ln r by r, ln r by r. So cos theta came outward, sin phi will be differentiated. So cos theta by sin theta, what that would be? Cot theta. Cot theta, and then ln r is there, and sin phi will be differentiated. Sin phi will be differentiated and will give you cos phi. So here ar cap, here I forgot to write. What I forgot to write? A theta cap, and lastly you are gonna get, this was a theta cap, and lastly you are gonna get a phi cap. At what point I need to calculate? 1 comma 30 degree comma 60. 1 comma 30 degree comma 60 degree. Okay. So r value is 1. So ln r 1, ln 1 will be 0. ln 1 will be 0. So these terms will go to 0. Only this term will be left. So what I am gonna get? 30 and 60. So cos 30, what will be cos 30? Root 3 by 2. And what will be sin 60? That will also be root 3 by 2 divided by r, ar cap. So what I am gonna get? 3 by 4 ar cap. Okay. So that's the answer. That's it. So these kind of calculation based question, there is 1% chance that these kind of questions can be asked, but still if you ever need to do the calculation, then you can do the calculation in the examination. Well and good, very easy till now. Let's see the physical significance of the gradient. What do you mean by gradient? So let's take an example. So these are the things I have written. This is the physical significance of a gradient, but you will not understand this. Let's take an example first. So a scalar field function is given. A scalar field function of what? Temperature. A scalar field function of temperature is given. So that is represented by Txy equals to 3z. So your temperature is varying with respect to z coordinate. So can you find the gradient of that? How will you find the gradient? Del by del x function f, that is 3z ax cap, plus del by del y function f, that is function f is t only, that is 3z ay cap, plus del by del z function f, that is 3z az cap. So this will give you 0, this will give you 0, what this will give you? 3 az cap. So what you are getting? This is what you are getting, that your gradient is coming out to be 3 az cap. Yeah, so your gradient is coming out to be 3 az cap. So it has some magnitude. What is the magnitude of this gradient? That is 3. And what is the direction of this gradient? That is az cap. Magnitude is 3 and direction is az cap. Now this magnitude is constant, right? This magnitude is constant. This magnitude is constant. Okay. So in this example, what did we show? That at different point you were getting different magnitude. Let's just say 130 degree 2, you are getting this magnitude, or you can say this gradient. If I had put some other point, then you would get some other magnitude or some other direction. So there your gradient was changing but as of now we have taken the example where gradient is constant. This gradient is constant. What is that gradient? 3, 3. The gradient is 3. And what is the direction of the gradient? That is az cap. That means at any point your gradient is 3 only. At any point the direction is az cap. Okay. So what does it show? So let's make the coordinate system. So this is our coordinate system. Y direction, z direction, y direction and x direction, x, y and z. Let's just say there is some point 1, 1, 1. So let me know what is your temperature at 1 comma 1 comma 1. What is your temperature at 1 comma 1? Let's just say this is 3z degree Celsius. So what is your temperature? Put 1 comma 1 comma 1 here. X is not there, Y is not there, Z is only there. So 3 into 1, 3 degrees Celsius. So at 1 comma 1 comma 1 your temperature is 3 degrees Celsius. Now what will your gradient say? So what your gradient is saying, very important line, listen with full concentration. So what your gradient is saying, if you walk in AZ direction for 1 unit, if you walk in AZ direction for 1 unit, then the increase in temperature will be 3 degrees Celsius. If you walk in AZ direction for 1 unit, then your increase in temperature will be 3 degree Celsius. So what is your AZ direction? This is our AZ direction. Let's change the color. This is our AZ direction. So in this direction, I need to walk for 1 unit. What do you mean by 1 unit? 1 unit means I can walk for 1 meter. So basically, if I walk for 1 unit, that means I will reach here. In Z direction only I am walking. That means only Z coordinate will change. X, Y coordinate will be constant. So if I am walking in Z direction only, that means only Z coordinate is changing. From 1 to 2 I am going. So if you walk in Z direction, for 1 unit, then your temperature will be increased by 3 degrees Celsius. So 3 degrees Celsius, and it is increased by 3 degrees Celsius. So 3 degrees Celsius plus 3 degrees Celsius. Your temperature should be 6 degrees Celsius here. So this is what they are saying. So from here to here I walked. And your temperature should be 6 degrees Celsius. Is that correct? Let's check out. So what is my temperature at point where I have reached 1 comma 1 comma 2? What is the temperature there? 3 into 2, 6 degrees Celsius. Yes. So the statement what my divergence is saying, sorry, not divergence, gradient. What my gradient is saying, that if you walk in AZ direction for 1 unit, then your temperature change should be 3 degrees Celsius. Now this change is the maximum change. What do I mean by that? So if I am walking in AZ direction for 1 unit, then this is how I will walk. Now let's just say in a random direction I am moving for 1 unit. From this point in a very random direction I am moving for 1 unit. So I will move like this. I will move like this, right? I am moving for 1 unit. In a random direction I am moving for 1 unit. From this particular point, that is 1 comma 1 comma 1. Tell me what will be its coordinate. X coordinate is not changing. I am assuming that I am not changing X coordinate. If I am saying that Y coordinate will change, so Y coordinate will change. So here it was 1 comma 1 comma 1. It could be somewhat greater than Y. I am moving in very random direction. Try assuming yourself. You are at 1 comma 1 comma 1. You are walking 1 meter here. Now the same distance you are walking in this direction. Once you go straight, ekdam, like directly you went straight. Now you are walking in this radial direction. So what will be your Y coordinate? Y coordinate will be changing. It could be like somewhat around 1.2. But what will be your Z coordinate? It will be certainly less than 2. Do you agree to this point or not? The Z coordinate will be certainly less than 2. Because if I am walking for 1 meter straight, then I am reaching at 2 point. So if I am walking 1 meter in this direction, then certainly the Z coordinate will be less than 2. Do you agree to this point? I am assuming the Z coordinate is 1.8. So what will be the temperature at this point? What will be the temperature at 1, 1.2, 1.8? What that would be? 1.8 into 3, 5.4 degree Celsius. So the temperature here is 5.4 degree Celsius. Now anywhere you could have walked. You could have walked here as well for 1 unit only. The same distance, 1 unit only. Here you could have walked for 1 unit. Here you could have walked for 1 unit. Here you could have walked for 1 unit. The maximum temperature you will get when you walk in AZ direction. So whatever the direction of gradient you get, that will tell you the direction of maximum change. Again I am repeating, whatever the direction of gradient you will get, that will tell you the direction of maximum change. Again once more, whatever the direction of gradient you get, that will tell you the direction of maximum change. That means you need to go in this direction to get the maximum change in your temperature. Are you getting this point or not? So this is what we have written. Let's read the second statement, direction of gradient. points in the direction of the maximum rate of change in V. And what does the magnitude show? Maximum rate of change in V per unit distance. If you go for 1 meter, if your distance is changing for 1 meter or 1 unit, then what will be the rate of change? What will be your change? And why I am saying maximum rate of change? Because the change will be maximum here. Here the change was, how much change it was? 2.4 degrees Celsius, right? Here what was the change? 3 degrees Celsius. So if you go in this direction, then you will have the maximum change. So it will always show the direction of maximum change. Are you able to understand this point or not? Everything is crystal clear? Right? Again, shall I repeat? Temperature function was given. I calculated the gradient. I got to know that there is some magnitude and there is some direction. So magnitude of the gradient was 3. Here the gradient was constant. So yeah, here the gradient was constant. At every point the gradient was same. But we are calculating the gradient at 1, 1, 1. So at 1, 1, 1, your gradient at 1, 1, 1. What was that? That was 3 AZ cap only. So this was your gradient at 1, 1, 1. Okay. So at 1, 1, 1, what it will tell you? So if you are standing at 1, 1, 1, you will see the gradient there. You saw the gradient, you go to know it is 3 AZ cap. So at 1, 1, you will receive a message that if you walk in AZ direction for 1 unit, then your temperature should change by 3 degrees Celsius. Then you walked in AZ direction for 1 unit, 1, 1, 2, your temperature changed by 3 degrees Celsius. And if you have walked in any other direction, here, there, for 1 unit only, then your temperature would not be changing for 3 degrees Celsius, it would be changing for lesser than that. So that's why it is said that it tells the maximum rate of change. Crystal clear? Okay. More things are there. Gradient will fail as well. Where it will fail, there I will tell you, and with a very good example I am gonna tell. Okay. So it will fail as well. So hold on to the video. A lot of interesting thing you are going to understand, even if you have studied gradient from anywhere. Like I will just completely open it up. So yeah. So let's remove this 2.4 degrees Celsius, 6 degrees Celsius. When you revise the notes, you will be able to understand all these things. AZ 1 unit, 3 degrees Celsius increase, AZ direction. Okay. Yeah. So notes are clear. Now one more thing is there. So what I am gonna do is that now I am gonna put a constant value to this function. Let us say I put a constant value 1. So what I am doing there, wherever my temperature is 1 degree Celsius, I am taking all these points and there I am making a plane. Let's see it. So what I am gonna do, this is my temperature function, right? This is my temperature function. So I am gonna keep it equals to 1. So what do you understand by that? That wherever your temperature is equals to 1 degree Celsius, at all the values of 3Z, where your temperature is 1 degree Celsius, you are marking all those points. So from here, what will be the surface you are getting? 3Z equals to 1. Are you getting this point? I have marked this equals to 1 degree Celsius. I have marked my temperature function equals to 1 degree Celsius. So from there, what is the equation of plane I am getting? 3Z equals to 1. So can I plot 3Z equals to 1? Yes. That will be your Z equals to 1 by 3 plane. This we have already seen in our, where we have seen all these things in coordinate system. So this will be your plane, Z equals to 1 by 3. Z equals to 1 by 3. So this is the plane, that is Z equals to 1 by 3. Now what do? I create a new temperature function. I am creating a new temperature function. So what I am doing, I am taking this one, this side, 3Z minus 1. So this is the new function I have created, 3Z minus 1. This is my new temperature scalar function. So according to this function, what will be my temperature on this surface? On this particular surface, according to this function, forget about this function now, okay? Forget about this function. Now we are going to discuss about this phi function. So according to this phi function, what will be my temperature on this surface? Tell me. 0 degree. Because Z is equals to 1 by 3. If you put Z equals to 1 by 3 here, phi T1 at Z equals to 1 by 3. What will be the temperature? 0 degree Celsius. So here my temperature is 0 degree Celsius according to phi T1. Okay. Next, one more function I am creating. Two function I am creating. There are two guys. One guy created 3Z minus 1 function. The other guy created 1 minus 3z function. Okay, so according to him as well, what will be the temperature at z equals to 1 by 3? What that would be? 0 degree Celsius only. So according to phi T1 and phi T2, here the temperature is 0 degree Celsius. Now for this particular function, and for this particular function, they are calculating the gradient. So what will be the gradient? Gradient of phi T1, what that would be? Here you are going to get 3ax cap. Sorry, 3az cap. Sorry, really sorry. You are going to get 3az cap. And for this, what they are getting? Minus 3az cap. For phi T2, what will happen? 1 is constant, and in z direction only it is, so minus 3az cap. You can simply apply this formula here, right? It is very easy. This will be 0, this will be 0. From here, what you are going to get? Minus 3az cap. So these two things I am getting. Okay, so let's first see this. So what this gradient function is telling me, that if you work for 1 unit in az direction, so phi T1 is supposed to go in az direction. Phi T1 is supposed to go in az direction, and phi T2 is supposed to go in minus az direction. Phi T2 is supposed to go in minus az direction. In both of the cases, the temperature should increase. Say yes or no? Phi T1 is supposed to go in az direction. What does gradient say? If you work in the given direction, if you work in the direction of gradient, then your function should increase. Here you are having 0 degree Celsius. If you work in az direction, then your temperature should get greater than 0. It could be 1 degree Celsius, it could be 2 degree Celsius, it could be 3 degree Celsius. But it will certainly increase. Are you getting this point? Again I am repeating. What does the direction of gradient shows? The direction of gradient tells that if you work in my direction, then your function, this function, that will increase. Here it is equals to 0 degree Celsius. If you work in az direction, then certainly it will be greater than 0 degree Celsius. This is what divergence, so this is what gradient says. So is that happening? Let's check. So here it was 0 degree Celsius. If you work in the upper direction, what you are going to get here? Z equals to 1. At z equals to 1, what will be the temperature? Phi T1 value at z equals to 1. What that would be? 2 degree Celsius. Here you are going to get z equals to 1 only, no? So your temperature from 0 degree to 2 degree Celsius increased. So if you are working in this direction, certainly your temperature is increasing. Let's talk about this guy. The other guy made this function. Then he calculated the, what he calculated? He calculated the gradient. Then gradient is saying that you go in minus az direction. Okay, he will go in minus az direction. If he goes in minus az direction, where it will go? This is z equals to 1 by 3. It can go to z equals to 1 by 6. Z equals to 1 by 6, or it can go to 0 as well. There is 0 as well, no? 1 by 3. It can go to z equals to 0 as well. So let's take a simpler example, z equals to 0. So it is going downward. So if it goes to z equals to 0, what is the value of phi T2 at z equals to 0? 1 degree Celsius. So here also temperature is increasing only from 0 to 1 degree Celsius. Here 0 to 2 degree Celsius. So what the gradient said? Gradient said that, to this guy gradient said that you work in az direction, your temperature will increase. Yes. To this guy gradient said that you work in downward direction, your temperature will increase. So gradient never went wrong. Whether you are making the function 3z minus 1 or 1 minus 3z, gradient is always telling you to go in the increasing direction only. So let's just say there was some scalar function. I equated it to a constant value. Then this would give me an equation of plane. If I equate the scalar function to a constant value, it will give me the equation of a plane. From the plane, I can get another function, another scalar function, that is 3z minus 1. If I find the divergence of that will always come in the perpendicular direction of the plane. Not divergence, sorry. If I find the gradient of that, really sorry, I am using word divergence because this is our next topic. So no divergence, gradient. So if I am finding the gradient of this, then it will always be in the perpendicular direction and it will always point towards phi greater than 0. Are you getting this point? Why did I write phi greater than 0? Because this was your phi equals to 0 function. Phi equals to 0 function. This was your phi equals to 0 function, right? Here phi was 0. If you go upward, your phi was increasing. So what did I say? If I take my scalar field equals to a constant value, then from this particular plane, I will get an equation of plane. From this particular plane, I can make another scalar function. I can make another scalar field. If I calculate the gradient of that particular field, it will be always perpendicular to the plane and will always point towards phi greater than 0. I deserve a like for this. Okay, so you can like the video. More things we are going to see. You will find it much more interesting. Now more interesting things will come. These things you can find in textbook, but what I am going to tell in the next slide, that you are not going to find in any textbook. That I can tell you. Okay, so I will tell where the gradient will fill. So as of now, is that clear to you? Again I am repeating this line. I am again repeating. So when I equated the scalar field function to a constant, then what I am getting? I am getting an equation of plane. From this plane, if I am making another scalar function and then I calculate the divergence of that, so that will always be perpendicular to the plane. That will always be perpendicular to the plane and it will point towards increasing direction of the function, increasing direction of the scalar function, or you can say phi greater than 0. Crystal clear? So these points I have already written. So I will erase this. In the next page you will find these points written. So phi t1 you will understand phi t2 minus az gap minus az and this 0 and this let's remove it up because already I am equating it. Downward I am equating it. Okay, yeah, so let's keep all these points. So what has been written? Phi xyz, sorry, f xyz, this was your scalar field that I am equating to a constant value. That means if I take this here and then if I am equating this to a constant value, so here I will get an equation of plane, because what I am doing, I am joining all the points where my fxyz is equals to c. I am joining all the points where my fxyz is equals to c. So I am getting an equation of plane. Equation of plane. From that equation of plane, what I am making? Another scalar field function. Another scalar field function. Another scalar field I am creating. Okay, another scalar field I am creating. Now if I calculate the divergence of that field, so that will be always pointing towards phi greater than 0 and the direction will be always perpendicular to the surface. So if I am given an equation of surface and I am asked to find the perpendicular unit vector of that, how can I find it? If I am given an equation of surface, that is x plus y plus z equals to 1, and I need to find the perpendicular, again I said divergence here, gradient. Did I say again divergence here? Gradient. Okay, it would be gradient. I am again and again using the word divergence, but please understand I am explaining gradient here, not divergence. So forget about divergence, only gradient you need to understand. Okay, yeah. So if the equation of plane is given, how can I calculate the perpendicular unit vector? What I am gonna do? I am gonna make a function. I am gonna make a scalar field function that would be x plus y plus z minus 1, or I could have made another function that could have been 1 minus x minus y minus z. Okay, then I will calculate the divergence of this. Again divergence I am saying. Then I will calculate the gradient of this. What I am going to calculate? Gradient of this. So what I am going to get? So del y del x x y z. So 1 ax cap plus 1 ay cap plus 1 az cap. Here what I am going to get? Minus ax cap minus ay cap. What I am doing? Del y del x, then this function, then del y ax cap certainly, then del y, then this function ay cap, then del y del z, then this function az cap. So these values I am putting, and then I am putting ax cap, ay cap, az cap. Okay, so what I am going to get? Minus 1 ax cap, minus 1 ay cap, minus 1 az cap. minus 1 AZ gap. So one vector, sorry, one gradient is pointing towards, both of the gradients are pointing towards perpendicular vectors, but one plane can have two perpendicular vectors, no? Like let's just say this is the plane, so it will have this perpendicular vector and another this perpendicular vector. So both, it will have two perpendicular vectors. So just by calculating the gradient you will get to know the perpendicular vectors. Just by calculating the gradient you will get to know the perpendicular vectors. So which perpendicular vector is useful for you, that you will get. Okay, if this is useful for me, then I will take this as my perpendicular vector. If this is useful for me, then I will take this as my perpendicular vector. How will I get to know which is useful for me? I will see the closed surface. If it is a closed surface, then which is going outward, that is useful for me. And if I get a if I need a inward one, then I would take inward perpendicular vector. So I would see which is required. So this I am getting, I will just calculate this, then I would know that other one will be just opposite. So other one will be this. I will calculate gradient of this function, which will be ax cap plus ay cap plus az cap. The other one will be just negative of that. So I don't need to calculate this. I will, from here only I can write it down. So I will take this one here. If I need to calculate the perpendicular vector of a surface, I will just take this one here and just calculate it. Just calculate the gradient. If I calculate the gradient, this is what I am gonna get, and then I can put this side, and then I can calculate the gradient. That would be the other perpendicular vector you will get, or otherwise only this perpendicular vector you calculate and just take the negative sign. So for a plane, if they are asking you to calculate the perpendicular vector, you just need to take the gradient. That's it. Okay. If I have used the word divergence anywhere, then please understand I was trying to talk about gradient only, not divergence. Okay. So both look same only, so sometimes I can use the word divergence, but I was always talking about gradient only. Okay. Now let's see the important point. So we have understood all these points now. Maximum rate of change in V per unit distance. Points in the direction of the maximum rate of change in V, and this is the point that about function I have written. Delta V or gradient of V at any point is perpendicular to the curve V equals to C. It is perpendicular to the curve V equals to C, and that passes through the point. And if phi is equals to V minus C or C minus V, then this direction will always point towards increasing direction of the function, that is phi greater than 0. Okay, well and good. Where the magnitude of divergence will fail. So let's take this example. So first you calculate the divergence. Again I said divergence. Where magnitude of gradient will fail. So let's take this example and calculate the gradient of this function. So calculate the gradient of this function. So what that would be? Del y del x square plus y square ax cap plus del y del x square plus y square ay cap plus del by del y plus del by del z x square plus y square az cap. So what you are going to get? 2x ax cap plus 2y ay cap. This is the gradient. This is the gradient you are getting. Okay, this time I was saying the correct word. This is the gradient you are getting. This is the gradient you are getting. Now this is a function of x, right? This is a function of x. So let's take a random point. I am taking the point of 1, 1, 1. I am taking a point of 1, 1, 1. At 1, 1, 1, what will be my gradient? 2ax cap plus 2ay cap. This will be my gradient, right? What will be the magnitude of the gradient? Magnitude at 1, 1, 1 I am talking about. That would be 1, 1, 1. That would be, let's take it 2D. It would be easier to understand. Okay, let's forget about the z component. It is in 2D. I am saying it is in 2D only. So let's forget about z component. Are you getting this point? It could be in 2D as well, it could be in 3D as well. If nothing is mentioned, I would consider there are 3 coordinates x, y and z. But now I am saying it is in 2D only. So only 2 coordinates are there. So instead of 1, 1, 1, I will write at 1, 1, because that will be easier to understand. That's it. Because this is the example we are taking to explain something, not as per the understanding of examination or anything like that. This is just taken to explain a particular point. So at 1 comma 1 comma at 1 comma 1, what you are getting? What is the magnitude? Okay, the magnitude here is at 1 comma 1 2ax cap plus 2ay cap. This you are getting 2ax cap plus 2ay cap. The magnitude will be 2 square plus 2 square and then under root. So 2 root 2. And what is the direction? For direction you need to calculate the unit vector. So that will be 2ax cap plus 2ay cap divided by 2 root 2. So what I am getting? Ax cap plus ay cap divided by root 2. Let's take this every information to the coordinate system. So at 1 comma 1 I am at 1 comma 1. This is my 1 comma 1. Okay. At 1 comma 1 this is temperature function only. So what is my temperature at 1 comma 1? X, Y, Z I should not mention, only X, Y I should mention. So what is my temperature at 1 comma 1? Txy at 1 comma 1, that is 2 degrees Celsius. So this is my temperature at 2 degrees Celsius. This is my temperature at 1 comma 1. Now what my divergence is saying? What my gradient is saying? Not divergence. What my gradient is saying? Gradient is saying that if you move in this direction, if you move in this particular direction for 1 unit, if you move in this particular direction for 1 unit, then your temperature will change by 2 root 2 degrees Celsius. If you move in this direction for 1 unit, then your temperature will change by 2 root 2 degrees Celsius. So in which direction I need to work? If you have good understanding, then can you tell me what will be this direction? Ax cap plus ay cap root 2. Ax cap plus ay cap root 2. Ax cap plus ay cap root 2. It will be somewhere here. Let me explain it. Let's make another coordinate system. Only 2D I am making, okay? Ax cap, ay cap. This is your ax cap by root 2. Ax cap by root 2. This is what I am assuming. And this is your ay cap by root 2. You are standing at this point. You are being forced, you are being pulled by the same force. In y direction by 1 by root 2 force. In x direction by 1 by root 2 force. Where you will go? In the middle. I am standing here. One guy is pushing me here. One guy is pulling me here. Both are pulling me on their side with the same force. So where I will go? Right in the middle I will go. Right? Right in the middle I will go. So right in the middle I will go. Making an angle of 45 degree because both forces are same. So this guy will go the same thing. This guy will do the same thing. So let's make it more clear. So here this is how it will go. Making an angle of 45 degree with x axis and y axis. Right? 45 degree and 45 degree. And how much I need to work in this particular direction? I need to work for 1 unit. In this particular direction I need to work for 1 unit. So tell me one thing, if I am working for 1 unit in this direction, that means how much I am working in x direction? Again I am repeating, if I am working in this direction for 1 unit, then how much I am working in x direction? 1 by root 2. Say yes or no? 1 cos 45. 1 cos 45. If you are working for 1 meter right from the corner, that means in x you are moving 1 by root 2, in y you are moving 1 by root 2. Very simple. 1 cos 45 and 1 sin 45. So 1 by root 2 and 1 by root 2. So here you must have worked for 1 by root 2 and here also you must have worked for 1 by root 2. So what will be this point? Can you let me know? That point will be 1 plus 1 by root 2. In x as well you have moved for 1 plus 1 by root 2 and in y as well you have moved for 1 plus 1 by root 2. So this will be 1.707. 1.707. Are you getting this point? So 1 by root 2 here you must have moved. And 1 by root 2 here you must have moved. So your new coordinate would have been 1 plus 1 by root 2 and 1 plus 1 by root 2. So directly I am writing it is 1.707, 1.707, and this is also 1.707. What is it is saying? If you move in this direction for 1 unit, then your temperature should change by 2 root 2 degrees Celsius. What is your temperature here? 2 degrees Celsius. How much it should change? According to magnitude of gradient. According to magnitude of gradient, temperature at 1.707 and 1.707, what should be the temperature? It should change by 2 root 2 degrees Celsius, right? So here it was 2 degrees Celsius, 2 degrees Celsius plus 2 root 2 degrees Celsius. So what temperature I should get? Let's take the calculator. You also calculate it. So this is according to the definition. This is not the actual calculation. This is just the definition. According to the definition, this is what I should get. So where is my calculator? Here is my calculator. So root 2 into 2 plus 2. So it should change by, here it was 2 degrees Celsius, no? Here it was 2 degrees Celsius. So it should change by 2 root 2 degrees Celsius. So 2 root 2 degrees Celsius, that means I should have got 4.82 degrees Celsius. This is the temperature I am expecting at this particular point. But what is the actual temperature? According to Txy, that is x square plus y square. What is the temperature at 1.707 and 1.707? What is the temperature? 1.707 whole square into 2, 5.82 degrees Celsius. Let's see again what happened here. You calculated the gradient 2x ax cap 2y ay cap. You calculated the gradient at a random point. You thought of 1, 1. You calculated the gradient 2ax cap plus 2ay cap. So it was asking you to go in the direction of ax cap plus ay cap by root 2. In this direction it was asking you to go for 1 unit so that your temperature will change by 2 root 2 degrees Celsius. So here you calculated the temperature which was 2 degrees Celsius. This temperature you calculated, it was 2 degrees Celsius. There is no doubt about that. If you put 1 here, 2 degrees Celsius you are getting. Then you are moving in this direction. In this direction you are moving. Which direction? Ax cap plus ay cap by root 2. So in 1 by root 2 you are moving here, 1 by root 2 you are moving here. If you are moving 1 unit in this direction, so that means you will reach to the point 1.707, 1.707. So as per the definition of gradient, the magnitude should tell you how much it should increase. So from 2 degrees Celsius to it should increase to 4.82 degrees Celsius. But when I put the value in the function, it is giving me the temperature is actually 5.82 degrees Celsius, not matching. So here your divergence is, your gradient is failing, but the direction is not failing, that's for sure. What do I mean by that? If you work for 1 unit here, let's just say if I work for 1 unit here, so where I will reach 1, 2. If I work for 1 unit in y direction, this is your x I am assuming, this is your y. So if I work for 1 unit in y direction, I will reach to the point 1, 2. What will be my temperature there? 1 square plus 2 square, 5 degrees Celsius. My temperature will be there, that is 5 degrees Celsius. I have worked for 1 unit in the upward direction. If I work for 1 unit in this direction, what is the temperature I am getting? 5.82 degrees Celsius. So the direction it will always tell correctly, but the magnitude can be different. Are you getting this point? So whenever you see any lecture, whether you see the lecture of MIT, whether you see the lecture of NPTEL, whether you see the lecture of any GATE educator, they are always talking about the direction because the magnitude will fail. When I studied this topic, I took this example and I invested my time there. Then I got to know that gradient is not even giving me correct result. Then I tried finding in textbook, like a lot of textbook I saw, but nowhere it was written. Then I asked the chat GPT because that is the last option. So that was inclined with my thought. That is the thing that, so this is the conclusion I have come up to, no one will ask you no one will ask you this in your examination. Okay, you don't feel like that you are wasting your time. You certainly have got to know a good new thing, right? You certainly have studied a new thing here, that the direction of gradient will always tell the correct direction, that if you go in this direction then there will be the maximum change. But what will be the change that can change? But in this here the change did not change. What do I mean by that? Here the gradient was telling me the correct change. Here the gradient was telling me that your temperature will increase by 3 degrees Celsius, and it was increasing. Why is that so? Because it was constant. It was constant. It was not a function of xyz. So at each point your gradient was 3 degrees Celsius only. At each point your gradient was same. But here, if you are walking from here to here, then your gradient is changing very rapidly. What do I mean to say is that at 1, 1 your gradient is, what is your gradient at 1, 1? 2 root 2. The magnitude I am talking about. At 1, 1 your magnitude of gradient is 2 root 2. This is the magnitude 2 root 2. But if you calculate at 1.7, if you calculate the magnitude of gradient at 1.7, so what that would be? 2 into 1.7 ax cap, 2 into 1.7 ay cap. So that will come out to be 3.4 root 2. So magnitude of gradient is changing very rapidly. So if your function is non-linear, here the function was non-linear. So if your function is non-linear, then your gradient will be depending on xy parameter. So here your gradient is also a function of xy. So if it is a function of xy and then there is a rapid change, if there is a rapid change in the value of gradient, then the magnitude of gradient will not give you the correct result. But certainly it will give you the correct direction, that you need to walk in this direction only. Is that clear to you? Everything is clear to you. So this small point that I have written here, note the change has to be uniform or small. Uniform means it should not be a function of x, y, z or rho phi z or r comma theta comma phi. If it is not a function of x, y, z, or if it is very small, let's just say if this was coming to be very very small, 0.001 degree Celsius, then also it would be fine. Then also it can detect the change carefully. What do I mean by that is that, just now I will explain it quickly. I will explain this point. So what it is saying, if you move by 1 unit, then your temperature should change by 2 root 2 degrees Celsius. If I say, if I am moving by 0.01 unit, if I move by 0.01 unit, then how much my temperature will change? 2 root 2 by 100. If you move by 1 unit, your temperature should change by 2 root 2 degree Celsius. If you move by 0.01 unit, then your temperature should change by 2 root 2 divided by 0.01, right? Oh, sorry, 2 root 2 into 0.01 into 0.01. So this much my temperature should change. So now what you need to do, you walk from 1, 1 to 1.00707 and 1.00707. Okay, because you are walking how much? You are walking for 0.01 unit. You are walking for 0.01 unit. That means you will reach this point. If you are walking for 0.01 unit, right, you will reach this point. Then you calculate the temperature according to the function given, x square plus y square. According to this function, you calculate the temperature. Okay. Then according to the theorem, how much change will be there? 2 root 2 divided by 100. So according to the theorem also you calculate the temperature. You will get the same temperature there, approximately same. Are you getting this point? What I am saying? Here I am having 2 degrees Celsius temperature at 1, 1. So how much it should change? 2 root 2 divided by 100. 2 root 2 divided by 100. Root 2 into 2 divided by 100. So it should change by 0.028. So from what was my temperature? 2 degrees Celsius to, initially it was 2 degrees Celsius. Here it was 2 degrees Celsius. It should be going to 0.028. So 2.028 degrees Celsius. It should be getting this much. Now if I put this point in the equation x square plus y square, what I am gonna get? 1.00707 whole square into 2. So 2.028. Approximately I am getting the same answer. So the same thing that I did with this point 1.707, the same thing I did with this point, and then I am getting the same answer. Then I am getting the correct answer from the definition of gradient, also from this equation as well, when the change was small. So if the change is small, then it is fine. But if change is large and it is not even constant and your function is non-linear, then your gradient, the magnitude of gradient will not tell the correct answer. This kind of questions can come in your interview. If you go in a very good interview in some IITs and you say that my RF is my interesting field, I am interested in RF, I am interested to do M.tech in RF and photonics. So these kind of questions can come there. They will give you this example and then they will ask you that what is direction is showing. Okay, it is showing. Then you will say that sir, magnitude shows this thing. Then they will ask you, go 1 unit and see if magnitude is saying the same thing or not. No, it is not showing. So the change has to be small. Why the change has to be small? Can anyone think of it? Why it is detecting the small change only? Can anyone think of it? Pause the video and try thinking of it. Hint is, see the definition of gradient. See the definition. See the formula of gradient. What is the formula of gradient? Del by del x. So it will see only the small change in x, small change in y, and small change in z. Are you getting this point or not? So if change is large enough, then it will not give the correct result. I hope this is clear to you. Every single thing about gradient from bottom to top, everything is clear to you. Say yes or no. So if it is clear, like the video and comment down. Okay, comment down something good, because I have spent a lot of time on this and making these examples, that how to make you understand this thing. It has taken a lot of effort, and if I receive some good appreciation from your side, then I will feel very good. Okay. So yeah, not matching these things, these point, okay, fine. Here, okay, here I need to erase a lot of things. So this might not help you in GATE examination, but whenever you attempt any question, there you will be very comfortable if you study the things in that manner. Okay, you will be very comfortable if you study the things in that manner. If you just study the things on top level, I could have only taught the definition, then we could have solved some problems, then that would be it. It will be helpful for your GATE examination, but you will not be that comfortable in your examination, that you will be always thinking that some formula I need to remember. What is the meaning of gradient? Again and again you will be mugging that up. Like, what is the meaning of gradient? What does direction? So but here everything is crystal clear. The example is also clear. The temperature will be in your mind. Whenever you see any question, the temperature will be in your mind. Now we will solve application based problem and you will be able to solve very quickly. So this is just the statement I have written, which I just told previously, that if for a finite moment in non-linear field, the field curvature or the change in the value of scalar field from one point to another point doesn't exactly follow the gradient's initial estimate. So what was the initial estimate? That it will talk about the maximum change, but that change is not the same. Okay, let's see some application based problem, but before that I will pause for some time. I will take a break, drink some water, and then we will start some problems. So you can start this problem, very easy. You need to find the unit normal to the plane at this point 1, 2, 3. Very easy. Just get the gradient and put 1, 2, 3. Okay, then you can solve these problems. This problem you can solve it by which system? Cartesian? No, spherical. Then solve this problem. This is a good problem, think about it. Then this concept I will explain, that angle between two planes are the angle between their normal vectors. The angle between two planes is equal to the angle between their normal vectors. So this is what I am going to explain. Then this question will be there. Then this point I have already explained in the previous lecture only. What is the angle between a plane and a vector? Okay, so you can get the unit perpendicular vector and calculate this angle. The 90 minus this angle will be the answer. Okay, then we will solve this question, which is very easy, and with that we will cover it up, and our next lecture will be on divergence. So I will take a break and then we will start the problems. Okay, yeah, so don't forget to like and comment down. Okay, then yeah, so we will start the application based problems. So let's solve this question. What you need to do, you need to find the unit normal to a plane at the point 1, 2, 3. So how you will do it? Unit normal you need to find, that means you need to take the gradient. So first I need to make a scalar point function, or simply scalar function. So my scalar function will be what? I will take for this side. So xy plus yz plus zx minus 4. You could have taken xy plus yz plus zx that side as well. You will get the same answer. I will show you how. So what do I need to do? I need to find unit normal. So what I'm gonna do? I'm gonna unit normal. An cap I am denoting it. So I will just take the gradient and then I will take the. I have taken the gradient and then I divided by the magnitude. Okay. So what will be my del phi? So del upon del x, then complete this function will come. So since I am doing it for the first time, that's why I am showing it to you completely. From the next time onwards, I will be directly taking the gradient. Okay. So here I will write down the complete function, but from next time onwards, I am not going to write down the complete function. So you just need to do the partial differentiation of this particular function. So what you are going to get? Dx xy. So y will be constant, x will be 1. Yz 0. Here z will be constant, x will be 1. And 4 0. Differentiation of 4 will be 0. You understood this point? Y will be constant, differentiation of x is 1. Yz completely constant, differentiation is 0. Zx, z will be constant, differentiation of x is 1. And 4 completely constant, differentiation is 0. Same goes for the next one. X will be constant, differentiation of y will be 1. So x plus z will be constant, differentiation of y will be 1. And this is completely constant. This is gone. Here ay cap should have come. So this is an error from my side. I should have written ay cap here. And here az cap will come. And in the next what will come? 0 y plus x. Y plus x az cap. So what will be the value? 1 2 3 they have written. So 2 plus 3 5, 1 plus 3 4 plus y plus x 3. So 1 plus 2 1 plus 3 and 2 plus 3. Okay, this is actually z. So we don't have any page, so I will add it up. So del phi you are getting 5ax cap plus 4ay cap plus 3az cap. 5ax cap plus 4ay cap plus 3az cap. But tell me one thing, it could be negative as well, no? If you had taken this xy plus yz plus zx on this side, so it could have been negative as well. So there are two possible answers. What do I mean to say is that you are finding a unit normal. This is your unit normal. So in opposite direction as well there could be unit normal, no? Let's just say this is your curve and you are saying this is my unit normal at this curve. So in opposite direction as well there could be another unit normal. So other unit normal could be just the negative of that. So first I will find this unit normal and then I will just take the negative sign. So my unit normal is 5ax cap plus 4ay cap plus 3az cap divided by its magnitude. What will be the magnitude? 25 plus 16 plus 9. So 50. Right? So this is one of the answer, or simply the negative of this. Simply whatever the unit normal you are getting, simply the negative of that will be other answer. So two possible answers are there. Because you are asked to find the unit normal, not in the increasing direction or decreasing direction, nothing like that. You are just asked to find the unit normal. So for that you also need to consider the opposite direction. So these kind of questions, if they are asked in MSQ, then you will click on both of the options. Okay, very straightforward problem. Just differentiate it, then write down the value and then just take the unit normal. Well and good. Let's move to the next one. Find out these values. So here R is given in spherical coordinate system. R is given in spherical coordinate system. So for only once I will write for spherical coordinate system what is the value of gradient. For spherical coordinate system, what is your gradient? Del phi. Del phi I am writing. So that is what you are going to write? Del R, R d phi r d theta, dr r d theta and r sin theta d phi. Okay, so from here you can write down ar cap plus r d theta. So 1 by r d by d theta and then phi, a phi cap. Here phi will also come here, so let's take f here. Instead of phi, let's take the function to be f, and here a theta cap would come. So let's take the function to be f, a theta cap, and then 1 by r sin theta. This formula you have to remember, there is no other choice you are having. Okay, anyway you need to remember the formulas. This is the function f, a phi cap. And trick also I have told, dr r d theta r sin theta d phi. So dr r d theta r sin theta d phi, then del f del f del f, ar a theta a phi, r theta phi. Okay, so first one del r. So only the r term you are having. If you put r here, what will be the value? 0. If you put r here, what will be the value? 0. You are differentiating r with respect to theta. You are differentiating r with respect to phi. It will be 0. It will be 0. Only this one will come in action. So I will write down only the final one. This one only. So del by del r, r ar cap. So what will be the answer? Ar cap. Second, del r square. So del by del r square ar cap. So what will be the differentiation? 2r ar cap. Right. Third one, del r to the power n. So del by del r to the power n ar cap. So what that will be? N r to the power n minus 1 ar cap. Did you get this point? N r to the power n minus 1, just the differentiation of this ar cap. What can you write down ar cap? What can, okay, we will see this question later on, or shall I show it here only, because I have written this question in the assignment video actually. So let's solve it here only. What is your ar cap? Vector r divided by magnitude of vector r. Do you agree? What is your ar cap? Ar cap is vector r divided by magnitude of vector r. Vector r divided by, what is the magnitude of vector r? That is r only. Magnitude of vector r is r only. All this information should be given in the question. I did not write it, that is my mistake. So here it would be given that actually your r is root x square plus y square plus z square. This is equals to magnitude of r vector and it is r. Did you understand this point? Root x square plus y square plus z square. What is r? R is root x square plus y square plus z square only in spherical coordinate system. If you remember, this is your r distance. So x, y and z, then you will reach r. So root x square plus y square plus z square. So that is only r. And we also write down the conversion as well. That if you go from spherical to Cartesian, how do we go? So that would be root x square plus y square plus z square. So this would be given. Now, this is what we get. So n r to the power n minus 1 r divided by r. So what you are going to get? N r to the power n minus 2 r vector. So sometimes this question is asked. I guess this has come in your GATE examination as well. What will be the value of gradient r to the power n? So n r to the power n minus 2 r vector. So this should be called gradient. Okay, this should not be called del. This is my just an error from my side, or you can say this is just my habit that I call it del. You should be calling it gradient. So next, gradient of 1 by r. Do we have the page? No. So here only we have to write down gradient of 1 by r. So what that would be? Differentiation of 1 by r with respect to dr. So what that would be? Minus 1 by r square and then r cap. Then you can write down in this manner as well. Instead of r cap, I will write ar cap, because everywhere I am writing ar cap. Then you can replace ar cap. If your option is not matching, then what you are going to do? Ar cap will be replaced by r vector divided by magnitude of r, which is equals to r only. So your option could be r vector divided by r cube and then minus sign. So this is how you can make another option as well. but for now this is what we are writing. Okay, and what about fifth one? So you need to take the gradient of ln r. So what is the differentiation of ln r? That is 1 by r, and then ar cap. What could be the other answer? Vector r divided by r square. Did you understand this point? Because how ar cap will be replaced? R vector divided by magnitude of r. So r vector divided by r. So r vector divided by r square. So this would be the answer. Okay. So in that manner you can write down all the answers. Well and good. Very easy question. So let's solve this question now. So first you need to find the gradient of w, and then you need to find the directional derivative. What do you mean by directional derivative? That I will tell you. So first let's find the gradient of w. So gradient of w. So first I will differentiate with respect to x and then put ax cap. Then differentiation with respect to y, ay cap. Differentiation with respect to z, az cap. So differentiating it with respect to x. So y square will be common and 2 will come and x square will be differentiated. So what will come? 2xy square. Here yz will be common. Differentiation of x with respect to x will be 1 only. If you are not able to do it directly, then first write it down. After 1 or 2 questions you will be able to do it directly as well. Now differentiation with respect to y. So x square will be common. Differentiation of y square, that will be 2y. So 2x square y plus xz will be common. Differentiation of y will be 1. Here differentiation with respect to z. So x square plus x square into y square. Differentiation with respect to z will be 0. And here xy will be common and differentiation with respect to z will be 1. So xy az cap. Now put this coordinate. What is the meaning of that I will tell you. So do not worry about that. First put this coordinate. What you are gonna get? Which vector you are gonna get? If you put this coordinate 2 minus 1 0. So 2 here you put. So this will be 4ax cap, right? And if you put on the next, then what will happen? Minus 8 ay cap. And if you put here, that would be minus 2 az cap. Right? Okay. Now what they are saying, at 2 minus 1 comma 0. First you calculate the gradient. What gradient will show? Gradient will show the maximum rate of change in a particular direction, and that too per unit length. So just talking about the direction. Here I am calculating directional derivative, so I am talking about the direction now. So what gradient will show? Gradient will show the direction in which maximum change is occurring. So this is the direction gradient is showing. So that is 4ax cap minus 8 ay cap minus 2 az cap. Now if you work in this direction, then your change will be maximum. Now what they are asking, if you work in this direction, then what will be your change? So this is what they are asking. If you work in this direction, then your change will be maximum. But if you are working in this direction, in this particular direction, then what will be your change? So let's just say this direction is something like this. This direction is something like this, which is 3ax cap plus 4ay cap plus 12 az cap. So they are asking directional derivative of dw by dl, that means directional derivative of gradient w in the direction of 3ax cap plus 4ay cap plus 12 az cap. That means what you need to calculate? You need to calculate the projection of this vector on this particular vector. Let's just say if I call this as vector A and this as vector B. So what I need to calculate? Projection of vector A on vector B. Projection of vector A, directional derivative. What do I need to calculate? Directional derivative. So projection of vector A on B. So first, whatever the gradient you find, you need to find if you are moving in this particular direction, then how much you would have got the change. So this is what they are asking. So what that would be? Projection of A on B. So that would be, if you remember it, A vector dot B cap. Projection of A on B. Here I am calculating the scalar value. In the option, if you are getting the direction as well, then you will put the direction, because I am finding the component of this on this vector. So if they are asking the direction as well, then you can put the direction as well. But here I am just asking the scalar value. So you need to see the option. If in the option direction is mentioned, that means if you see ax cap, ay cap and az cap, then you will put B cap here. So this will be the magnitude and this will be the direction. Direction we know, we are certainly moving in the direction of B only. But for this question, we will only calculate the magnitude. So A vector dot B cap. So A vector is what? 4ax cap minus 8ay cap minus 2az cap dot B cap. B cap, vector B is this 3ax cap plus 4ay cap plus 12az cap. So 3ax plus 4ay, that will make 5, and 5 plus 12, this will make 13. So this you are going to get 13. How did I do it? Very quickly, because I know 3 and 4, 3 square plus 4 square under root, that will make 5. 5 square plus 12 square, that would make 169, that means 13. So this is how I could do it very quickly. Now what I am going to do, 12 minus 32 minus 24. 12 minus 32 minus 24 divided by 13. So minus 44 divided by 13. So that's the answer. Okay. Directional derivative of the gradient in a particular direction. So you just need to take the component of gradient in that particular direction. So component of gradient, this was my gradient only, component of gradient in this direction. Okay, well and good. Let's see the next one. So before going to the next question, first let's see a concept. What will be the angle between two surfaces? So this is one of the surface. Do I have any other option? Okay. This is one of the surface, this is the other surface. I need to find the angle between them. This is one surface, this is the other surface. So what will be the angle? This will be the angle. This will be the angle. This will be the angle. Okay. This will be the angle. Right. So you can see one surface, two surface, this angle I need to find. So what I am doing, I am taking the perpendicular component of this vector, I am taking the perpendicular vector of this plane, and I am taking the perpendicular vector of this plane. These two planes are there, taking the perpendicular vectors of both of the planes. Now I know how to find the angle between two vectors. So this angle I know how to find. So I can find this angle. Now by geometry solid, what will be the value of this angle? What is the value of this angle? 90 degree. What is the value of this angle? 90 degree. So what this angle will be? This is a quadrilateral, right? This is making a quad. This is a quadrilateral. So 90, 90, this is theta. So this angle would have been, this angle would have been 180 minus theta. This angle is 90, this angle is 90, this angle is theta. So this angle would have been 180 minus theta. So this angle would also have been 180 minus theta. Say yes or no? Right? All these angles are theta, theta, theta only. Basically, the angle between two planes is theta. So this angle would have been 180 minus theta. So if I find the angle between two vectors, I will get 180 minus theta. Is it necessary? No. Look, the angle between two planes is theta. This is what you are saying. But if I say the angle between two vectors is 180 minus theta, am I correct? Yes. Look, this is how the planes were cutting. So this plane would be going here and this plane would be going in this manner, right? Okay. So this angle we are measuring, that is theta. I could have measured the other angle as well, no? 180 minus theta. Right? The other angle could also be the answer. So what I am going to do on top level, what you need to do, first I will find the unit vectors, unit perpendicular vectors. I will measure the angle between them. One angle I will get. That would be my one of the angle. For the second angle, what I am going to do? Subtract 180 from that, or subtract the angle from 180. If I get theta equals to 70 degree, so other angle will be 110 degree. So I guess this thing I told you in the previous lecture as well, that always we take angle, usually we take angle lesser than 90 degree. So if they are asking this question in NAT, then you will click on this option. If they are asking in MSQ, then you will click on both of the options. Okay, and if they are asking MCQ, then you see which is the best possible option. If you are having this option as well and this option as well, then go with 70 degree. If you are having only 110, then go with 110. Okay, so preference is always around this guy, which is less than 90 degree. Okay, between a plane and a vector as well. If you are finding an angle between a plane and a vector, this example we have already taken previously. So between a plane and a vector. So if you are finding that particular angle, that also we usually take lesser than 90 degree, but in the option greater than 90 degree can also be mentioned. So first you find out the unit perpendicular vector and then you just take the angle between them, and from there you will get to know the values. So let's see the question. So you need to find, this is plane 1, this is plane 2, you need to find the angle of intersection at this particular point. So what I'm gonna do, for plane 1, I'm gonna calculate this value, which is gradient of phi 1. So 9 I will take this side, 9 I will take this side. So 9 I am taking this side. So what I'm gonna get, 2x ax cap plus 2y ay cap plus 2z az cap. And if I put the values at this particular point, what that would be, 4 ax cap plus 2 ay cap minus 4 az cap. Okay, and if I take the unit vector, so this is how it is not shown, but just to write it down, I am showing it cap. This is not how it is shown. Okay, this is not how it is generally shown, but here I am writing it. I hope you will be able to understand that I am finding the unit vector only. So I am finding the unit vector now. So what that would be, 4 ax cap plus 2 ay cap minus 4 az cap divided by magnitude. 16, 16, 32 plus 4, 40. Right? 2, 1, 2. 2, 1, 2. 2, 1 minus 2. Okay, then 16, 16, 32. Yeah, that's what I was thinking. 6. 32 plus 4, 6, no? It would be 6. And what about del phi 2? 2x ax cap plus 2y ay cap plus az cap. Right? So 2, 1 minus 2. So 2 ax cap plus 2 ay cap, and this az cap, it is not even having the term of z. So that will not even come. Ay cap plus az cap divided by 3. So what will be the angle cos theta? That will be multiplication of these two. Sorry, dot product of these two. I should not say multiplication, dot product of these two. Okay. So 8 plus 4 minus 4 and 18 here you are getting. Okay, let me check the calculation. 8 plus 4 minus 4. Let me check the calculation. Yeah, so there was a slight error in the calculation. Here 4 would come. Here 4 would come and this would become root 21. So 16 plus 4 plus 1, root 21 would become. Okay, so this would be 16 plus 4 minus 4 divided by 6 under root 21. So you are getting 8 by 3 under root 21. So answer will be, I will just put it in this manner only, or I can calculate as well, no issue. 8 by 3 under root 21. So under root 21 into 3 reciprocal into 8 cos inverse 54.41 degree I am getting. 54.41 degree, and other answer could be 180 minus this value, that would be 125.58 degree. So these are the two possible answers. Well and good. Let's move to the next question. So angle between a vector and a plane, I have already told. What will be the angle? Two angles could be there. This angle theta, other angle could be 180 minus theta. So what you need to do, you just need to calculate the unit perpendicular vector and then find the angle between them. So unit perpendicular vector I will find out, then I will find out the vector between, so I will find out the angle between these two. So what that angle will be? That angle will be alpha. And what will be my theta? Theta will be 90 degree minus alpha. So this will be my answer. So this we have already seen in the previous lecture. So now let's solve this question. Try doing it on your own. Very good question. We need to find the angle at which this line, the equation of line is x equals to y equals to 2z, intersects the ellipsoid x square plus y square plus 2z square equals to 10. What would be the equation of a sphere? X square plus y square plus z square equals to 10. X square plus y square plus z square equals to 10. That could be the equation of a sphere. This is ellipsoid. That means if you just squeeze the sphere, if you just squeeze it, you will get ellipsoid. How will you get ellipse? How will you get ellipse? This is my circle. If I just squeeze it, I will get an ellipse. So if you just squeeze the sphere, you will get ellipsoid. And then there is a 3D line, x equals to y equals to 2z. This is the 3D line which is cutting. So basically the line is passing like this. From in between, the line is cutting. Assume this as a ellipsoid. So line is passing like this from here in between. So that is cutting on these 2 points. So angle I need to find. This angle, what angle I will make, this angle what I will make, and this angle what I will make, and this angle what I will make. So that I need to find. Okay. So what I'm gonna do. So it is cutting at these 2 points, this point and this point. So I can find the perpendicular vector at these 2 points. I can find the perpendicular vector at these 2 points. What will be the perpendicular vector at a point? What you need to do, first you need to draw the slope, first you need to draw the tangent. So first I will draw the tangent on this point. This will be the tangent, and now perpendicular on this tangent, perpendicular on this particular tangent, perpendicular on this particular tangent, that will be 90 degree. So this is what my gradient will give me. What I need to do, first I need to find out this value, whatever the value I get, then I will find out the gradient of this ellipsoid. And if I put the point, if I put this point, whatever the point I get, if I put this particular point, then I will get this vector. Are you getting this point? What is your perpendicular vector? Are you getting this? At this particular point, first you need to, let's just say if I ask you on this particular point, what will be your perpendicular direction? So how do you tell a perpendicular direction? So first you will draw a tangent, and then whatever that is perpendicular to that particular tangent, that is known as perpendicular direction. What will be the perpendicular direction on this point? Draw a tangent, and whatever that is perpendicular, that will be the angle. Okay. So better I would make it somewhat more. So 90 degree only it should look, so let it be. So this is your 90 degree. Okay, but what do you need to find? You need to find this particular angle. So first I am gonna find this angle, which I am assuming as angle between this line and this particular vector, which I am assuming as theta. If I am able to find theta, then we will see what we can do. So let's first try writing the theta. So first point is, first I need to find out these intersecting point. I do not even know these intersecting point. So how will I find out? I have two equations. I can solve both of the equations, right? So I have one of the equation, x square plus y square plus 2z square equals to 10. If both are intersecting, that means the values here will satisfy both of the equation. So from there, from this particular equation, x equals to y equals to 2z, x equals to y equals to 2z, what I can know, that x is equals to y. So in place of y, I can replace x. This is equation 1. And in place of z, I can replace x by 2. From here, what did you get to know? That x is equals to y and z equals to x by 2. So I can replace x by 2 here. So x square by 4 will come here. X square by 4 will come here. So x square by 2 you will get here. X square by 2 is equals to 10. So what I am gonna get? 2.5 x square is equals to 10. So 10 by 2.5, what you are gonna get? X equals to plus minus 2, right? This is the simple calculation which you can do. So x equals to plus minus 2 I am getting. So what will be the points? What will be the value of y? Y will also be plus minus 2. And what will be the value of z? Z will be plus minus 1. Z will be plus minus 1 because z is x by 2. So that's the scene. So this point would have been anything I can take, 2 to 1 I am taking this point, and minus 2 and minus 1 I am taking this point. So both of the points are satisfying this equation as well and this equation as well, right? Now no one will have the doubt, sir, why did not you take 2, minus 2 and minus 1? What is the reason behind that? No, I am not going to take 2, minus 2 and minus 1 because x equals to y equals to 2z. So if x is 2, then y will also be 2 and z will be 2 by 2, that means 1. Now can I find out this vector? I have 2 points. I have 2 points. Can I find out this vector? This vector I am calling as vector A vector I am calling. So can I find out the A vector? If I go in this direction, that would become, yeah. So A vector I need to find out. If you need to find out this vector and these 2 points are mentioned, then what that would be? This point minus this point, right? This we have already seen. So 2 minus 2, 4 ax cap plus 2 minus 2, 4 ay cap plus 1 minus 1, 2 az cap. Now what I need? I need this perpendicular value. I need this perpendicular value. So how will I get that? I'm just gonna find my gradient at this particular point, 2, 2, 1. So gradient at 2, 2, 1. What is the curve? What is my phi? So x square plus y square plus 2z square. X square plus y square plus 2z square minus tan is equals to 0. So I need to find the gradient. 2x ax cap plus 2y ay cap plus 4z az cap. First I am just finding the gradient at point, at which point? 2, 2, 1 I am finding at 2, 2, 1. Char 4 ax cap, 4 ay cap plus 4 az cap. So what will be your unit vector? Unit perpendicular vector, that would be 4 ax cap plus 4 ay cap plus 4 az cap divided by its magnitude. What that would be? 4 square plus 4 square plus 4 square. So 4 square I can take common. So 4 will come outward into root 3, right? 4 square plus 4 square plus 4 square. So 4 square will come common, 1 plus 1 plus 1. That would be 3. So 4 square will come outward, then it will come out as 4 because there is under root. So 4 root 3. So what you are getting? Ax cap plus ay cap plus az cap divided by under root 3. So that will be your del phi cap. Del phi cap. Okay. So this is my del phi cap and this is my vector A. So I need to find out this angle. So I am gonna get this angle only. This is your vector A, this is your del phi cap. So I am gonna find the angle. So what will be your cos theta? This is your vector A. If you need to find out A cap, what that would be? A cap would be 4 ax cap plus 4 ay cap plus 2 az cap divided by 6, right? Divided by 6. So cos theta is A cap dot del phi cap. So 4 into 1, 4 into 1 and 2 into 1. So 4 plus 4 plus 2. 4 plus 4 plus 2 divided by 6 into under root 3. That would be 5 by 3 under root 3. This is your cos theta. Theta is equals to cos inverse 5 by 3 under root 3. Under root 3 into 3 reciprocal into 5 and then cos inverse. So 15.79 degree. So this is what you found. This theta you have found. What do you actually need? Do you need this theta? No. You need this angle. Are you getting this point? Angle between this line and the plane, right? Angle between line and the plane. What is your line? This is the line. And what is your plane? If you need to find plane, that means you need to take the tangent here. So this angle I need. So alpha plus theta, I know that is what? 90 degree. I know that alpha plus theta is equals to 90 degree. So my theta will be equals to 90 minus 15.79. So 74.21 degree. So that would be the answer. Did you understand this point? You find out this angle, you find out the angle between, what did you find out? You found out this angle between vector and the unit normal. Angle between vector and the unit normal. This is the angle you find out. Now you need this angle, alpha. What is your alpha? 90, sorry, what you need here, alpha I have taken otherwise. So what will be your alpha? Alpha will be 90 minus theta. So 90 minus theta, 72.41. Are you getting this point? This I have taken as theta, this I have taken as alpha. So let me interchange it, otherwise you are getting confused. So angle, actual angle I need is alpha, and what you are finding, theta. So what will be your alpha? Alpha will be 90 minus theta. So this is what we have done. My alpha is 90 minus theta. So one of the angle will be this angle, other angle will be this angle. Other angle will be 90 plus theta, or you can say 180 minus alpha. One angle is alpha. Okay. Other angle will be 90 plus theta, or you can say 180 minus alpha. Again I am repeating, 90 plus theta or 180 minus alpha. So other angle or theta could be 180 minus 74.21. .79 degree. Okay. What is the next doubt anyone can have? That sir, why did you calculate the angle here only? Why did not you calculate the angle here? You could have done the same thing, that sir, at this point you could have find out the perpendicular vector. This vector you could have find out. Sir, that this would be your first you will draw a slope at this particular point. First you will draw a slope, then you find out the perpendicular vector, then you find the angle between them. This is your 90 degree angle. Then you find the angle between them. If you are able to find out the angle, then other angle would be 90 minus this angle. Why did not you do it? You try doing it, you will get the same answer. You do it on your own, you will get the same answer. Just take this example. If I have find out this angle, then what this angle will be? 180 minus alpha. What this angle will be? 180 minus alpha. And what this angle will be? Alpha. So there are only two possible answers, alpha and 180 minus alpha. In this picture it is more clear, but here it is not clear. So what you are going to do, you find out first this vector, which will be negative of this vector, and then calculate the perpendicular vector on this particular point, calculate the perpendicular vector on this particular point, and then find out this angle. And then another angle will be, if you find out this angle, then subtract that angle from 90 degree, you will get the angle between plane and the line. And the other angle will be 180 minus this particular angle. Are you getting this point? What you need to do? This is your line and this is your perpendicular vector. So you can find out the angle between them. Yes. Will you be able to find out this vector? Yes, that vector will be simply the negative of that, because a vector is going in this direction, then other vector will be negative of that. Then this perpendicular vector also you will be able to find. What you are going to do? Calculate the gradient and put these values, -2, -2 and -1. Then you will get this particular vector as well. Then you can find out the angle between them by dot product. Once you get that angle, this is not the angle you desired. You desired the angle between this, what do we call, tangent and this line. So that angle will be 90 minus this angle. Whatever the angle you get, you will, let's just say you get 20 degree here. So that angle will be 60 degree. This is 20 degree you are not gonna get. This angle you will get, other angle will be 180 minus this particular angle. 180 minus this particular angle. So that angle will come same only, 74.21 degree and 105.79 degree. So those will be two possible answers. Okay, so only two possible answers could be there. It feels like that there are four possible answers, but no, there are only two possible answers. So this you can check out on your own. Okay, so that's it about our gradient. I hope you enjoyed the lecture. I hope you have got every single thing about gradient. Gradient will not be discussed in much detail from now onwards. But divergence and curl, which we are going to study in the next lecture, they will be discussed in much detail later on as well. When we go to EM wave part, when you go to electrostat and magnostats part for electrical and instrumentation student, and for ECE student, when you go to EM wave and transmission line, even in your antenna as well, I will use del product, I will use that divergence and curl, which we are going to study in next lecture. So those will be highly used. So that's why I dealt this topic in much detail here only, because this is the end of gradient. Very rarely you are going to use gradient in your EM wave. Only when you study potential, there it might be used, because your electric field is negative gradient of the potential. So there you will be using it, otherwise it will be very rarely used. I hope you must have understood the core concept of gradient. Okay, let's meet in the next lecture. Next lecture might be a little boring. Okay, might be a little boring, because in one lecture itself it will be very tough to give the all information about curl and divergence. So slowly we will move in that particular series about curl and divergence. So slowly we will move. So certainly you will find it much interesting. I will tell every single thing about that. So yeah, I hope you enjoyed the video. So you can put a like or you can share it. Okay, thank you very much.